right, this is third grade, Module 4, Lesson 5, and we're going to continue studying the connection or the relationship between rectangles and multiplication, and in this case, the arrays, the multiplication array. All right, so now what I mean by that is, let's say we're given a portion of a rectangle. So here it is. Now, ideally, what this means is the student is going to say, oh, I know. They're going to imagine a grid, perhaps, superimposed. And then they're going to say, oh, this 3 right here means there's going to be 3 tiles going in each column. And this 7 means there's going to be 7 columns, all right? So it's going to be 3 by 7. So the students would then know that they need to fill in, okay, here's the rest of the grid, all right? So they're going to fill it in. So that now they can see that we have a 3 by 7 array. All right, and that's essentially what the students are going to be working on in this, is having a picture in their mind of the completed array, even when they're only given a portion of that array. So we're going to do a bunch of these problems on this page. So let's get started. It says, use the centimeter side of a ruler to draw the tiles. All right, and then skip count to find the unknown side length. So the idea, teachers, is skip counting. That's kind of a precursor to multiplication. So we're really working towards that standard algorithm for finding the area of a rectangle. Simultaneously, our kids are going to be practicing their multiplication because they are indeed third graders and they need practice with multiplication. And then we're supposed to write a multiplication sentence for each of these rectangles. So in this first rectangle, we see that we've been given a height of 4, and we're told that the area is 24, but we're not told what is the width of this rectangle. So find the unknown side length. You notice they call it side length. They don't call it length or width. And we're not going to be hung up on vocabulary at this point of the game. So our students are going to skip count. 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12. Now I haven't really been skip counting, but now I can see, oh, 4, 8, 12, 16, 20, 24. And so I know the missing length was 6. The missing side length is 6. So really I should put 6 centimeters right here is our missing length. All right, in the same way, let's go over here, and we've got a missing length here. A given length is 6, and we're told that the area is 24 centimeters. So the idea is we need another, we're going to count 1, 2, 3, 4, 5, 6, and then we're going to go add some more tiles. 7, 8, 9, 10, 11, 12. And now I can see that here's my skip counting. 6, 12, 18 is going to be at the bottom down here. And then 24 is going to be at the bottom right here. So I'm not going to fill in the rest, although I could real quick if I wanted to. It would look like this. So we know that our one side length is 6 centimeters. Our other side length, which is this one going across, is 4 centimeters. So I'm going to put a 4 down here, and we have an area of 24. I'm going to scooch down here. So now we have a side length of 5, and we're told that the area is 15 square centimeters. So we know that we have a 5 here. We know that the area is 15. And so we can predict that this answer is going to be a 3. The missing value is going to be a 3. And sure enough, if we count 1, 2, 3, 4, 5, and then this is going to be 10, then this is going to be 15. So there's our skip counting, 5, 10, 15. So indeed, our missing length going across up here is 3 centimeters. In fact, you can even see it, right? Here's one, and here's one. All right. And then the last problem, way over here, we have a side length of 3 and an area of 15. So we know that we can put in a 3 here, and the area is going to be 15, which means our missing value is 5. And if we wanted to, we really could. We could count. We could go 1, 2, 3, 4, 5, 6, and there's our skip counting. We could do 7, 8, 9, and then we could do 10, 11, 12, and then 13, 14, 15. And so we can see our missing length going across is 5 centimeters. So in this problem, we have Allie, and she makes a rectangle with 45 square inch tiles. And she arranges the tiles in 5 equal rows. Then the question is, how many square inch tiles are in each row? So first, let's get the idea of what this 5 equal rows is going to look like. So we're going to take her tiles and we're going to put 1, 2, 3, 4, 5. So there's our 5 rows. And then we're going to go, okay, we're going to keep going and keep going and keep going in each of these rows. And we're going to have the same number in each row. And the question is, well, how many do we need? We know that right here, there's 5 inches. And the question is, what does this number have to be if we're going to use 45 tiles in all, 45 square inch tiles? So really, what that's saying is 5 times what is equal to 45? Well, 5 times 9 is 45. So that's saying in each row here, we need to have 9 tiles. So let's see if that works out. So far, we've got 1, 2, 3, 4, 5, 6, 7. And now we could do, oopsies, I don't want that. Let's see, how am I going to do that? I'm going to send this all the way to the back. Now I should be able to move these. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's do that again. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to keep going. So a little magic of video editing means I've placed all my tiles, and you can see it's 5 up and down and 9 left and right. So the side lengths are 5 and 9, and that's 9 inches technically. And if you counted all of these tiles, we would indeed get 45 square inch tiles. And so the missing length was 9 inches. So how many square inch tiles are in each row? And the answer is 9. And that is 3rd grade Module 4, Lesson 5, where we're connecting rectangles to the arrays and really multiplication.